So here is some information. It says plot 7 points on the graph of the parabola that has an axis of symmetry at x equals -2 and a maximum value at y equals 4 and has an a value of -1. So many students got confused with this, right? How do we do this? Well, let's read a bit of it at a time and understand what that means. If the parabola has an axis of symmetry at x equals -2, we need to understand what an axis of symmetry is, what it looks like. The axis of symmetry at -2 would be a dotted line, a vertical dotted line going right through the x of -2, okay? So there's the axis of symmetry at -2. What does that mean? That the vertex itself has to be on this green dotted line. It might be up here at 10, opening down. It might be right here on the x-axis itself, opening up or opening down. It may be right here, but the vertex is going to be somewhere on this green line. Do you guys understand? Now, what is the vertex? Well, we know that the vertex is either the highest point of the parabola, if it's opening down, or the lowest point of the parabola, if it's opening up. It says that it has a maximum value at y equals 4. So we know the vertex has to be here. What's the y value right here? It's 0. What's the y value right here? It's 1. Right? Y value right here is 2. Y value is 4 right here. So we know that the vertex is going to be right here. The maximum value is 4. So just by knowing that the maximum value is at 4, you already know that it opens down. But to make it nicer, you want to use the pattern from that point to see how it's going to actually play out. Now the pattern is going to be 1, 1, 2, 4, 3, 9, but it's opening down because the a value is negative. Okay, so the a value is -1, which means that we're going to be able to use the pattern 1, 1, 2, 4, 3, 9. If you want to say, oh no, but the a value is -1, okay, you could change the outputs by multiplying them by -1. That way you get a -1, a -4, and a -9, right? But the bottom line is your pattern is 1 over, 1 down. So you have one dot right here at the vertex, you go 1 over and 1 down, you put a dot there. Actually, I'm going to put another dot right there on the vertex. Then you go back to the vertex, and you're going to go 2 over 4 down. 1, 2, 1, 2, 3, 4, and put a dot right there. And the final part of the pattern is from the vertex 3 over and 9 down. So you're going to go 3 over from the vertex 1, 2, 3, 9 down, 1, 2, 3, 4, 5, 6, 7, 8, 9, and put a dot right there. And of course, you could map these dots to the other side of the axis of symmetry. So this guy is 2 units away this way. This one is, no, I'm sorry, my bad. This one is 1 unit away. So 1 unit this way is right there. This one's 2 units away. 2 units away is right there. And this last one is 1, 2, 3 units away. So 1, 2, 3 units this way. And those are the 7 points that you need. Plot 7 points of the graph that has the axis of symmetry at x equals -2 and the maximum value of y being 4. So on this one, I actually give you the vertex, right? It says it has the vertex 7, -9. So that's where you start. Go to 7 on the x and -9. It's going to be way down here. That's -9 right there. Okay. And then, of course, if you were drawing it on paper, of course, you would have an axis of symmetry going right through there. But we need more points. They tell us that the a value is +2. So you can't use the pattern 1, 1, 2, 4, 3, 9 as it is. What you have to do is modify the outputs of the pattern by multiplying by your new a value, which in this case is 2. So you'd be multiplying by 2, multiplying by 2, multiplying by 2. So instead of 1, 1, it's 1, 2. Instead of 2, 4, it's 2, 8. Instead of 3, 9, it's 3, 18, right? So this is the new pattern from your vertex. Let me highlight it here. 1 over from the vertex 2 up, 2 over from the vertex 8 up, and 3 over from the vertex 18 up, okay? So we're going to first plot our point, 7, -9, which we already did. So let's take one of these points, and from the vertex, we're going to go 1 over, 2 up, and put a dot right there. And then we're going to get another point and go to the vertex and go to the next part of the pattern, 2 over, 1, 2, 8 up. 1, 2, 3, 4, 5, 6, 7, 8. Put a dot right there. And the last one, from the vertex, you're going to go 3 over 1, 2, 3, and 18 up. That's going to be way up here, 18. I think I counted that right. And of course, you're going to map them over to the other side of the axis of symmetry. This is 1 unit away, so go 1 unit this way. This other one is 2 units away, so go 2 units this way. And this last one is 1, 2, 3 units away, 1, 2, 3 units this way. Put a dot right there. Hit submit, and that will be the 7 points that you needed for this parabola that had the vertex at 7, -9, and has an a value of +2. So this is as hard as it gets right here when I don't give you the vertex. You have to find the vertex. How do we find the vertex? Using the vertex formula. After all, the vertex is a coordinate, an x value and a y value. You find that x value using the formula x equals -b over 2 times a. And just like I always say, please put equals and then put negative parenthesis instead of -b over 2 times parenthesis instead of over 2 times a. That way, when you identify the b value of 2 and the a value of 1 in front of the x squared, it's really easy to plug in a 2 right there and a 1 right there. Up on top, you have a -2. On the bottom, 2 times 1 is +2. That means that the vertex x value is a -1. So -2 divided by +2 is -1. That's your x value. You plug in that x value into the x values, right? That -1, you're going to plug it into the x values. So it'd be smart to rewrite this whole thing, but with parentheses instead of x's. So go y equals x squared plus 2x minus 8. We just, instead of x's, put parentheses, and now we're actually going to be able to plug in the x value of -1 into those x's, which means into those parentheses. So we have a -1 right there and a -1 right there. And from here, you could type this into the calculator exactly the way it is, into the scientific calculators we have, and it'll actually give you the y value when you hit equal. Or you could do it by hand the way I'm about to with PEMDAS. We're going to do exponents first before multiplying or adding. So -1 times -1, that's +1. Then we have 2 times -1, that's a -2, right? +2 times -1 is a -2. And the -8, we're just going to bring that down. So that's really a 1 minus 2 minus 8. That'll give us a -9. So the y value equals -9. So the y value of our vertex is -9. That's the most important point. That's what we plot first. So let's take this and put it at -1 on the x and -9 on the y. There it is. And then from that point, we could use the pattern 1, 1, 2, 4, 3, 9. Why is that? Because the a value is 1. So we are able to go from the vertex 1 over, 1 up. And then you could go back to the vertex, go 2 over, 1, 2, 3, 4 up. And then back to the vertex 3 over and 9 up. 1, 2, 3, 4, 5, 6, 7, 8, 9 right there. And of course, there's an axis of symmetry running right through that vertex x value of -1. So you could map those over to the other side. You could take this point that's 1 unit away and go 1 unit this way. You could take this point that's 2 units away and go 2 units this way. And you could take this one that's 1, 2, 3 units away, 1, 2, 3 units this way. And those are the 7 points that you need for the correct parabola here. Of course, if you were on paper, you would actually draw your parabola through these dots and you would put arrows on it. So this is as hard as it gets, right? You have a quadratic trinomial equation. We need to graph it. They specifically want us to plot 5 points. So let's begin by finding the most important point, which would be the what? The vertex. And the vertex is either the highest point or the lowest point of the parabola. It's actually a location somewhere on this xy plane. And a location is a coordinate, which is an x value and a y value. How are we going to find the vertex? We're going to use a formula, x equals -b over 2 times a. But when you use this formula, I always want you to rewrite it, negative parenthesis over 2 times parenthesis. That way you don't make a mistake. Now, all you got to do is identify that the b value is -28 and that the a value is -2. So negative 28 goes in the top parenthesis and negative 2 goes in the bottom parenthesis. So up on top, you have a negative negative, which becomes a positive. So you really have a positive 28 over 2 times negative 2 is negative 4. So you really have 28 divided by negative 4. So what is 28 divided by negative 4? Your answer is x equals negative 7. Yay? Okay, so you barely have the x value of your vertex, that's negative 7. You still need the y value. You have the x, you need the y. Anytime you have an x and you want the y, all you have to do is take that x value and plug it in to your x's. Plug in a negative 7 right here and a negative 7 right there. Now, this is where I see most students make mistakes. They make, maybe you're too lazy and you don't want to rewrite this, but you should do what I do right now. I'm going to rewrite this. Y equals negative 2 x squared. Check it out. Here it goes. Y equals negative 2 x squared minus 28x minus 93. Can't see that 93. I'll put it in red. Minus 93. Okay. Anyway, notice that when I said x's, I put parentheses. And there's a square on the x, so I put a square on the parentheses. And then right here, instead of x, I put parentheses, right? So why do I put the parentheses? So I could safely plug in the x value of negative 7. So when you plug in that negative 7 right there and right there, with the parentheses, you will not make a mistake. All you have to do is type this in exactly the way it looks like on the scientific calculator, hit equal, and it'll give you the y value of your vertex. If not, you could go through and use PEMDAS by hand, right? So PEMDAS, you're going to do parentheses, then move on to exponents. Negative 7 to the second power. Negative 7 times negative 7 is positive 49, but you still need to multiply it by the negative 2 in the front. So times negative 2, that'll be a negative 98, okay? And then right here, we have a negative 28 times a negative 7. And of course, use a calculator, and you'll get plus 196. I got that from the calculator. 28 times 7. Negative 28 times negative 7 is positive 196. Then you bring down the minus 93. And from left to right, negative 98 plus 196. That is a positive 98. Then positive 98 take away 93 is 5. So what equals 5? Y equals 5. Okay, so your y value is 5, the y value of the vertex. So here's your vertex y value. I put 5, so there's your vertex. That's the most important point. Negative 7 on the x, 5 on the y. Let's go to that location and plot that vertex. Negative 7 and positive 5. And that's your vertex. Now, from that point, you could use an input-output table, an XY table, and plug in some numbers and pull out some answers. Or you could go with the pattern, but you would have to modify the pattern. Okay? So modifying the pattern, you would have to first write down the pattern 1, 1, 2, 4, 3, 9, but you'd have to multiply the outputs of your pattern by that new a value of negative 2. So you have to go times negative 2 times negative 2 times negative 2, giving you a new pattern. Instead of 1 over 1 up, instead of 1 over 1 up, it's 1 over 2 down. And instead of 2 over 4 up, it's 2 over 8 down. And instead of 3 over 9 up, it's 3 over 18 down. Okay? So your new pattern is 1 over 2 down from the vertex, and then 2 over 8 down, and then 3 over 18 down. So from the vertex, you're going to go 1 over and 2 down. So that's where you plot your next point, 1 over, 2 down. Then you go back to the vertex, and you go 2 over and 8 down. 1, 2, 3, 4, 5, 6, 7, 8. And of course, you have an axis of symmetry right through that vertex. And you map the coordinate from one side to the other. And this, it also is 2 units away from the axis of symmetry, so map it over 2 units this way. And ladies and gentlemen, we have 5 points. That is your parabola. If you were doing it on paper, you'd actually draw your parabola, put some arrows on it. But since it's on quizzes, you just submit these 5 points that they asked you to plot, and you'll get full credit. So on this question, they want us to plot 5 points We know it's opening down because the A value is negative. And let's graph it. Let's start by finding the most important point, the vertex. And the vertex is a coordinate. It's an x value and a y value. And you find the x value using the formula negative b over 2 times a. And when you use that formula, please replace it with parentheses, negative parenthesis over 2 times parenthesis. And all you got to do is identify the b value of 12 and the a value of negative 3. That way you could easily plug in the b value of 12 up there and the a value of negative 3 down there. So what do we have? We have a negative 12 divided by 2 times negative 3. That'll be x equaling, let me rewrite it, negative 12 over negative 6. Why? Because 2 times negative 3 is negative 6. So it's really a negative 12 divided by negative 6, which is a positive 2. So we just found the x value of the vertex. Again, x equals 2. And whenever you have the x and you want the y, all you need to do is plug in your x value of 2 into the x's. So I recommend rewriting this exactly the way it is, but instead of x's, put parentheses. That way you could safely plug in your x value, in this case of 2. So let's first rewrite it. Y equals negative 3x squared plus 12x minus 8. And then you could plug in the 2's right in there. And then you could type this into the calculator, or you could do it by hand, thinking of PEMDAS. So let's do exponents first. 2 to the second, that's 4. But you need to multiply it by negative 3. That'll give you a negative 12. And you still have the 12 times 2 right here. That'll be a 24, but with the plus sign in front of it. And the minus 8 will come down. So you really have negative 12 plus 24 minus 8. Negative 12 plus 24, that's actually 12. And 12 minus 8, that is 4. And what did we just find here? We just found the y value of our vertex. The y value is 4. So let's go to that most important point, the location 2, 4. 2 on the x, 4 on the y. Whoops. So 2 on the x, 1, 2, and 4 on the y. That's your vertex. We know that there's going to be an axis of symmetry going right through it. But we need more points. So you could go to an input-output table, but I would rather use the pattern 1, 1, 2, 4, 3, 9. But this pattern is for when your a value is 1. But in this case, the a value is negative 3. So what you need to do is multiply the outputs by negative 3, the outputs of the pattern. So 1 times negative 3 is negative 3. 4 times negative 3 is negative 12. 9 times negative 3 is negative 27. So instead of the pattern being 1 over 1 up, it's going to be 1 over 3 down. And instead of going back to the vertex and going 2 over 4 up, it's going to be 2 over 12 down. And instead of going back to the vertex and doing 3 over 9 up, it's 3 over and 27 down. Now, you're not even going to use all those, but let's go from the vertex and do the first part of the pattern, 1 over 3 down. So I'm going to get a point and go 1 over and 1, 2, 3 down and put a dot right there. And then I'm going to go back to the vertex and go 2 over and 12 down. So going back to the vertex, 2 over and 12 down. 1, 2, 3, 4, 5, 6, 7. Or here's another idea. Maybe instead of that, we could find the y-intercept of this parabola by setting x equal to 0, and your y-intercept will be the location 0, negative 8. So you could do that way as well. 0, negative 8 right there, okay? Which means that it would be over on the other side also. 1, 2, 1, 2 right there. And of course, you could map this one over to this other side. And that's what we're doing. And that is a total of 5 points right there. Once again, I modified the pattern. So instead of 1 over 1 up, it's 1 over 3 down, 1 over 3 down. Go back to the vertex. Instead of 2 over 4 up, it's 2 over 12 down, 2 over 12 down. You get to right there. If you went back to the vertex and went 3 over, not 9 up, but 3 over 27 down, 3 over 27 down, you're off the graph. So that's why it's only asking for 5 points. You got 1, 2, 3, 4, 5, 5 points. Of course, if you were graphing this on paper, you would draw your narrow parabola like that with arrows on it. Man, oh man, check out this A value of -1/2. That's going to change things up. All right, let's graph this thing. Again, you're going to begin by finding the most important point, which is the vertex. So I'm going to put a number 1. I'm going to write the word vertex right here. The vertex is a coordinate. It's an x value and a y value. You find your x value by using the formula x equals -b over 2 times a. And when you use that formula, I always say write down negative parenthesis over 2 times parenthesis. And of course, you identify the b value of -4 and the a value of -1/2. So you plug in the -4 right there and the -1/2 right here. So up on top, we have a -4, which ends up being a +4. So I'm going to do it. So I'm going to write over here, x equals, I have a +4 up here, divided by what? Divided by 2 times -1. And on the calculator, 2 times, not -1, 2 times -1/2. And on the calculator, 2 times -1/2 is -1. So you really have 4 divided by -1, which is a -4. So you just found that x equals -4. That means that the vertex x value is -4. So if you know the vertex x value and you want the y value, all you have to do is take that x value of -4 and plug it in to the x's. Okay. The safest way to do that is to rewrite this, but instead of x's, put parentheses. That way you could safely plug in the -4. And I recommend rewriting it first without the x values, but with the parentheses. Y equals -1/2 with parentheses instead of x, with a square on the outside of the parentheses, minus 4x, but instead of x, we'll put parentheses -2 at the very end. And of course, we're plugging in the x value of -4 into those parentheses. If you don't have it set up like this with parentheses, you're going to get the wrong answer. At this point, you could just get a scientific calculator and type in -1/2 parentheses and type it all in, and it'll give you the right answer. Or you could do it the way I do it right here using PEMDAS. We're going to begin with the exponents. -4 times itself is +16. -4 times -4 is +16. But you still need to multiply it by -1/2. And with the calculator, -1/2 times +16, that's a -8. And over here we have a -4 times a -4, that's a +16. And we have the -2 at the very end that came down. So from left to right, we owe $8, have $16. So -8 plus 16, that is a +8. And then a +8 take away 2, that will give you your final answer of 6. And that is your y answer. Y equals 6. So we just found the y value, the y equaling 6. So we put the y value of 6 right there. So there's our most important point, -4, 6. Let's go to that location and put our vertex there. -4 on the x, +6 on the y, and there's our vertex. -4, +6, okay. And we know that through that point, there exists an axis of symmetry. You can't actually draw it on quizzes, but I'm just gonna write it here so you can see me reflect the points easily from one side to the other. So we do need more points. So one option is to do an input-output table and plug in some x's that are close to this x value of -4 and pull out answers, but that requires a lot of work. What we could do that's even better is to use the pattern that I asked you to memorize at the beginning of this section, the pattern 1, 1, 2, 4, 3, 9. However, you have to modify this pattern according to the new a value of -1/2, okay? So the a value is -1/2, which means you have to multiply the outputs. That 1, you have to multiply it by -1/2. The 4, you have to multiply it by -1/2. The 9, you have to multiply it by -1/2. So when you multiply the 1 times -1/2, you're going to end up with -1/2 or -0.5. This is getting messy. Let me put a little border around this. And when you multiply the output 4 times -1/2, you'll get the nice value -2. And when you multiply the 9 times -1/2, you're going to get the kind of ugly value -4.5, -4.5, okay, -4.5. So when you try to use this new pattern, instead of 1 over and 1 up, you're going to go 1 over and halfway down. So 1 over and halfway down, you're not going to be able to do that on quizzes. You're going to try to go 1 over and halfway down, but it's not going to let you stop right there. It's going to jump all the way over here. So in other words, you cannot use the point 1 over and halfway down on quizzes. Now, if you were graphing it by hand, yeah, you could put that red dot there and put the red dot over here on the other side, but we're not graphing it by hand, we're graphing it on quizzes. So we need a pattern that works nice from the vertex. This next part of the pattern, 2 over, 2 down, that works nicely. Check it out. 2 over and 2 down, and you put a dot right there, okay? And of course, now you could map that over to the other side. This is 2 units away from the axis of symmetry, 2 units this way, put a dot right there. And so far we have 3 dots on quizzes. If we were doing it on paper, you'd have a total of 5 dots already. But right here on quizzes, we only have 3 and we need a total of 5. So if I went 3 over and 4.5 down, 3 over 1, 2, 3, 1, 2, 3, 4 and a half down, it's going to be right here in between. And of course on quizzes, it won't let you put it right here in between. So if it were on paper, you could graph it there and you could map that red dot over to the other side over here to that halfway point. But we know that that's not possible on quizzes. You can't stop the coordinate at a halfway point. So we need more points. How could we find another point? Now you're probably thinking, well, I already used my pattern and I only have 3 dots that I could put on quizzes. What else could I do? You could always find the y-intercept. How do you find the y-intercept? All you have to do is set x equal to 0 and solve, and that'll tell you your location of where your parabola is going to cross the y-axis. Now you could already see it's probably going to cross right here at 0, maybe at -1, maybe at -2, but it's going to cross somewhere right here. Let's find out where it actually crosses the y-axis by finding the y-intercept. And how do you find the y-intercept? You set x equal to 0 and solve, and that's really easy to do when you plug in a 0 right here. 0 squared is 0, 0 times -1/2 is 0, 4 times 0 is 0, 0 take away 0 is 0, and 0 take away 2 is -2. So the y-intercept will be at 0, -2. So it's going to cross right here at that location. So that's where I put my next coordinate, right there at that location, okay? And of course, you're going to be able to map it over to the other side. It's 1, 2, 3, 4 units away, 1, 2, 3, 4 units away. And now we really do have 1, 2, 3, 4, 5 points of this graph on quizzes. Submit these 5 points exactly the way I have them here, and you'll get full credit. Of course, if you were doing it on paper, you would actually draw it through that halfway point, through that point, through that halfway point, through that point with arrows on it. Same this way. So that's how you would graph it on paper. Anyway, let's move on to the last question. This last one is equally challenging because it has an a value of 1/3. So let's begin by finding the vertex. And how do you find that coordinate, that vertex? You use the formula x equals -b over 2 times a. And when you use the formula, please go with parentheses, negative parenthesis over 2 times parenthesis. That way, when you identify that your b is 4, you can plug it right into the parentheses, nice and easy. And when you identify that your a is 1/3, you plug that in right there. So up on top, we have a -4. So that's what we have. Up on top, we have a -4. And on the bottom, we have 2 times 1/3. If you do that on the calculator, that'll be 2/3. So you really have -4 divided by 2/3. And if you type that in with the calculator, you type in -4 divided by 2/3, it'll give you your final answer, which is -6, okay? Now, if you don't have a calculator, you would end up writing it horizontally, like this, -4. Instead of the division bar, you put divided by 2/3, okay? Let me actually write it over here. -4 divided by 2/3. And we should remember that when you divide by a fraction, you really change the division to multiplication and you flip the second fraction. So it's really going to be a -4, the division changes to multiplication, and the 2/3 changes to 3/2. And then you multiply the top with the top, and you'll get -12. and the bottom with the bottom, and you get positive 2, which means that the x value is negative 6. Now, guys, don't freak out. The calculator will do it all. In other words, if you type in on the calculator the fraction button and up on top put a negative parenthesis with the 4 inside, and on the bottom 2 parentheses 1 with the fraction 1/3, and then close parenthesis, hit equal, it'll give you the answer negative 6. So the vertex x value is negative 6. How do you find the y value? Simply plug it in. Y equals 1/3 x squared plus 4x plus 9. And we are plugging in the negative 6 right in there. And again, the calculator will do all of this for you. You got to type it in exactly the way it is, with the fraction 1/3, with the parenthesis, with the negative 6 on the inside, parenthesis closed, with the square on the outside, and it'll give you your final answer. I'm actually going to show my work doing the exponents first. Negative 6 times negative 6 is positive 36. But when you multiply it by 1/3 out here, that ends up being 12. Okay? You could do that with the calculator. 1/3 times 36 is 12. And then over here, when you multiply a 4 times negative 6, you'll get a negative 24. And then you could also bring down that plus 9. So from left to right, 12, take away 24, that's negative 12. And negative 12 plus 9, negative 12 plus 9 equals negative 3. So y equals negative 3. So this is your answer, y equals negative 3. That means that your y value of your vertex is negative 3. And we could plot that point now. That's the most important point. Negative 6, negative 3, and you put a dot right there, okay? Now, from this dot, we know that there's an axis of symmetry that runs right through it. I know you can't draw this on quizzes, but I just want to make it easy to understand that you could reflect any point from one side to the other. Now, you need more points. So I recommend writing your pattern 1, 1, 2, 4, 3, 9, and then you got to modify the outputs of your pattern. These are the inputs. The 1, 2, 3 are the inputs. The 1, 4, 9 are the outputs. You got to modify the output by that new a value of 1/3. So you need to multiply 1 times 1/3, which will give you 1/3. You need to multiply 4 times 1/3, which will give you 4/3. And you need to modify 9 times 1/3. And if you do that on the calculator, it'll give you 3. And that's the only part, the only nice part of the pattern, of the modified pattern, that you could actually graph on quizzes. Because remember, even though your new modified pattern is from the vertex go 1 over 1/3 of the way up, 1 over 1/3, it's not going to let you put the dot there. When you try to move this dot from there at 1/3 of the way up, it won't let you. So what will it let you do? It'll let you do this last one, 3 over 3 up. So let's do that. Let's go 3 over 1, 2, 3, and then 3 up, 1, 2, 3, put a dot there. And of course, you could reflect that dot to the other side of the axis of symmetry. It's 1 unit, 2 units, 3 units away, 1 unit, 2 units, 3 units away. Put a dot there. And you have your parabola so far, but you need one more point. How are we going to get another point if we already exhausted the pattern that we have here without plotting fractions? Well, remember, the y-intercept is key. The y-intercept is the location of where this parabola that's opening up, where it's going to cross the y-axis. I'm predicting somewhere right here, maybe 8, maybe 7, maybe 6, maybe 10, I don't know. But it looks like it's going to pass somewhere up here. How do you find out where it's going to cross the y-axis? By setting x equal to 0 and solving, okay? So that's why I put the coordinate with the x value being 0. Algebraically, that means to plug in 0 where your x's are at, and that pretty much makes everything 0, because 0 squared is 0, and 1/3 times 0 is 0, and 4 times 0 is 0. Everything becomes 0, plus 9 will give you a 9. So when you plug in 0, you get out a 9. That is the location, 0, 9. 0, 9 is right there. This is where it's going to cross the y-axis, and that is an actual point right there. And it asked us to plot 4 points. There it is, 1, 2, 3, 4. Of course, if you were doing this on paper, you would actually draw your parabola going through those points, going through that y-intercept value like that. Okay, I hope this helps.